All right, so for today, the last thing you need to do is complete worksheet 4 on pages 9 and 10. This should be due tomorrow, and we'll go over it first thing in part of the hour tomorrow. We will also take a quiz doing this stuff, so you want to make sure you're familiar with it. Anything that doesn't make sense, make sure you come ready to ask questions on it. So I'll do number 1 with you like I did on the last worksheet, and then let you work through the other parts to the best of your ability. There is one typo on number 3, so if you think you got this and don't need to keep watching the video, that's fine, but I've made a note of it on this Google Slides, so make sure you check that, because there's a number that didn't print for number 3. So what you're going to do for this is, number 1, it says a tube has a piston located. So this is like a closed tube, because the air can't travel there with the piston there. So what we learned is we always need a node on that closed end, and we need an antinode on the open end. So for the first mode, if you look at your notes from Monday, when we did resonance, for an open or a closed tube with one end closed, you have the antinode on one, or the node on the closed end, and an antinode on the open end, and then just connect those with 2 single lines. You want the simplest, most basic pattern. Then the step that they're not giving us on here that we did in the previous worksheet is you had to figure out how many waves that was to figure out the wavelength. So this is 1/4 of a wave. So to figure out the wavelength, you take the total length of the tube, which is 0.8 meters, divided by the number of waves. So 0.8 divided by 1/4 would be 3.2. So 1/4 of the wave is 0.8. So the whole wave should be 4 times longer than that. So the wavelength is 3.2 meters. They don't give us the frequency, so we need to fill that in. But what we do know is we have the equation that speed equals wavelength times frequency, or if you prefer, using the triangles for algebra, speed is wavelength and frequency on the bottom. So we know the speed of sound is 340. So that will be our speed for all of these, unless we are not in air. And then the frequency we're looking for, and the wavelength we just figured out was 3.2. So the 340 divided by 3.2, that one I would need a calculator to do. So 340 divided by 3.2 gives me 106.25 hertz for frequency. So that's the first one. Now if you use your notes for the second mode, we're going to add one more node in there. So we're going to have a wave pattern that looks something like this. This is a half of a wave. This is a fourth of a wave. So we have a total of 3/4 of the wave. The tube length is still 0.8, but now we're going to divide it by 3/4, and then we would get the wavelength by doing 0.8 divided by 3/4 or divided by 0.75. Which gives me a wavelength of I'm going to round that to 1.1 meters. I got 1.066667, but I'm going to round it up to 1.1 meters. And then we'll do the same thing. Take the speed, 340, divided by the wavelength of 1.1 to get a new frequency of 309. It's 309.09. I'll round it to 309 hertz for that one. Now this third problem is a little bit different. So here they give us the wavelength and they give us the frequency. So I can take the wavelength times the frequency to get the wave speed. So basically on this worksheet, what you're going to do is try to figure out your unknown variables. So this wave speed's a little bit different. And sound doesn't always go 340. It can be different if it's like in a different medium. Maybe there's a different gas in the tube. Maybe the temperature of the air is different. 356.96, let me round that up to 357 meters per second. So then I now know the speed, and now I need to figure out how long this tube is right here. Oh, by the way, this is the second mode, because notice these two patterns here are the same pattern. So this is also the second mode, or the second harmonic. So now I need to figure out how long this tube is. Let me erase my marks here. So to do that, we could go back and do that equation, but backwards. So I know my wavelength is 0.92, and that equals the length over 0.75, or over 3/4. So then I would multiply both sides by 0.75. So it cancels out here. And then the length of the tube should be 0.92 times 0.75 gives me 0.69 meters. So that's number one. Now I'm not going to do the other problems for you, but number 2 is fine. There's no issues there. But on number 3, there's lengths that should have been printed here. The number you need to have there is 0.6 meters. So those were not printed on there and should have been printed on there. You still need to find this number, and you're going to need to know what that is. But you need the lengths for the first 2 on number 3 in order to be able to solve it, and that wasn't printed for you. So good luck with that. Anything you would like to ask, just come ready on Thursday, and I'll go over any questions you have. For 5th and 6th hour, you always have Mr. H to give you a hand.